Hi students, good evening. Welcome to Civilianz ISRO Marathon. Okay, so let's start the subject. Okay, so today we are starting a new subject. The subject name is Fluid Mechanics. So before starting the subject, let's see some information about the exam. Okay, so currently the total number of vacancies is 39. The post is Scientist Civil, and the exam date, as you already know, that it is on the 17th of December. Okay, so the last time the ISRO conducted the Scientist exam was on the 2020. So after 3 years they are conducting the exam, so the vacancies may increase on the due course. Okay. Okay, the subject we are discussing here is fluid mechanics. So before starting the subject or before starting the section, let's give you an outline about this section. Today we will be discussing some of the previous year questions asked in the exams, and we will be discussing the relevant theories also. Okay, so you can comment the answers in the chat box and we will be discussing that. Okay, so before going into that, let's see the weightage of the subject over the previous year exams. Okay, in 2013 the weightage of this subject was 33 marks. Okay, 33 marks, which means 2013 to 2020 for each question the weightage was 3 marks and the negative marking was 1. Okay, so in that scenario, in 2013 the weightage was 33 marks, 2014 it was 24 marks, 2015 21, and in 2019 it was 24 marks, and it is 2020 it was 15 marks. So on an average 8 to 9 questions has been asked on the previous years. Okay, so keep that in mind when you prepare for this subject, because the questions has been asked from this subject and some of these questions are really tough. On the other hand, some of these questions are very easy also. Okay, so we will be discussing all the relevant topics in this area. Okay, so let's start. Are you ready? Please comment. Are you ready? We can start. Okay, then the first question. So it was asked in ISRO 2013. It is a problematic question, but the answer is in theory. Okay, so the question is, if the volume of a liquid weighing 3000 kilogram is 4 cubic meters, 0.75 is its. So read the question once more. If the volume of a liquid weighing 3000 kilogram is 4 cubic meters, then 0.75 is its. This is the question. Can you comment the answer? (3,000 kilogram is the weight. Unit is important, even though it is the weight they have been asking, but the unit is in kilogram, and the volume is in 4 cubic meters. Then what will be 0.75? What will be 0.75? Okay, so the answer is specific gravity. 0.75 is the specific gravity. Okay, let's see what are the theory behind this question. Okay, so the weight is 3000 kilograms, so it is a mass. Mass is 3000 kilogram and the volume is 4 cubic meters. What is 0.75? Okay, let's see what is density or the specific mass. Okay, so density or the specific mass is equal to the mass of the liquid per unit volume. Mass per unit volume. So 3000 is the mass, right? It is in kilograms, so mass is in 3000, and the volume is 4 cubic meters, right? So it is 3000 divided by 4, we will get 750 kilogram per meter cube. So this is the specific mass or the density. So when we see the options they are having specific weight, specific mass, specific gravity and specific volume, right? Okay, then what is specific gravity? Specific gravity is defined as the density of a given fluid or the liquid to the density of the standard fluid. In case of liquid, the standard liquid is water. Okay, so the given liquid density is, the density of the given liquid is how much? It is 750, right? And the density of water, we all know that. Everybody knows, right? It is 1000 kilogram per meter cube. So when we divide, we get the specific gravity of that given liquid. The specific gravity S over G. You can follow any notation, that is not an issue. So S over G, so we can say that it is 750 divided by 1000 and we will get an answer as 0.75. Right? 0.75. So 0.75 is the answer. Okay, Bini has said the correct answer, Bina has said the right answer, good. Okay, so the answer is specific gravity. Okay, so specific mass has been asked, the answer will be what? It will be 750 kilogram per meter. And there is one more thing, specific weight. So what is specific weight? Simply specific weight is nothing but your specific mass multiplied by the acceleration due to gravity. Specific mass multiplied by acceleration due to gravity, you will get specific weight. So it will be 750 into 9.81 because the G value is 9.81. So we multiply, we get an answer which is higher than this value. So it is not an option. So the answer is specific gravity. Please try to answer the question with options, right? A, B, O, C. Okay. So moving on to the next question. Shall we? Okay. So the second question is, Newton's law of viscosity is the relation between. Newton's law of viscosity is in the chapter viscosity or in the area viscosity. So what gives the relation for Newton's law of viscosity? It is a relation between. We are having four options. The option A is pressure, velocity and temperature. Option B, shear stress and rate of shear strain. Option C, shear stress and velocity. And option D is rate of shear strain and temperature. Okay, Vaishnav has answered, Binya has answered. Okay, good. Okay, yeah, all of you are correct. The answer is shear stress and rate of shear strain. Okay, that is Newton's law of viscosity. So Newton's law of viscosity states that the shear stress developed between two layers of liquid. Okay, so it is the concept is like that. When we consider a drop of liquid, it can be divided into a number of thin layers. A number of thin layers, right? A number of thin layers. So each layer will be having of different velocity. Okay, if u is the velocity of one layer, the adjacent layer will be having a slightly different velocity. Let that will be u plus du, and they are separated by a distance known as dy. Then, according to Newton's law of viscosity, the tau is proportional to du by dy. The tau is proportional to du by dy. This is known as Newton's law of viscosity. Newton's law of viscosity. Right. So tau is your shear stress, du by dy. It has many names. One of that name is velocity gradient. So it is velocity gradient. We can write as velocity gradient, or we can also write as rate of shear strain. Rate of shear strain. Okay. Rate of shear strain. Right. So tau is proportional to du by dy. So it gives the relation between the velocity gradient and the rate of shear strain. All of you have said the right answer. Good. Okay. So the answer for this question is option B. Okay. Next question. So this question was asked for ISRO 2017. A similar question was asked for 2018 also. This is also related to viscosity. The question is, what is the unit of kinematic viscosity? What is the unit of kinematic viscosity? Your options are meter square per second. Option B is Newton second per meter square. Option C, Newton second per meter cube. And option D is kilogram second per meter square. Please read the question before answering. What is the unit of kinematic viscosity? Kinematic viscosity. Okay. What will be the unit of kinematic viscosity? Okay. Again. Okay. Here there is a confusion between option A and B. Many of us get confused. Okay. Many of us get confused because we have read both option, or we have studied both option A and B in the viscosity area itself, right? So what is the unit of kinematic viscosity means the answer is not B. Some has written B. The answer is option A, meter square per second. So there are mainly two viscosities. Already Newton's law said that tau is proportional to du by dy, right? So for changing this proportionality to an equal to sign, we will put a constant. So tau is equal to mu into du by dy, right? This mu is known as, remember, This mu is known as dynamic viscosity. This mu is known as dynamic viscosity. And the unit of mu is, that's why many of you get confused with the option A and B. The unit of mu, which means the unit of dynamic viscosity, is Newton second per meter square. And this is the SI unit. When we go to the CGS unit, it will be dyne second per centimeter square. It will be the CGS unit. And this dyne second per centimeter square is also known as poise. So remember, poise is the CGS unit of dynamic viscosity. Okay. We will be having one more viscosity, that is known as kinematic viscosity. That is known as kinematic viscosity. So what is kinematic viscosity? The notation is nu, small letter v in a bend form, nu. Okay, that is mu, this is nu. So what is kinematic viscosity? Is the ratio of dynamic viscosity to density of the fluid. The ratio of dynamic viscosity to density of the fluid. And the unit of that in SI unit is meter square per second. This is the SI unit. And when we move to the CGS unit, it will be centimeter square per second, and it is also known as Stokes. It is also known as Stokes. It is the CGS unit, right? Okay, so the answer for this question is, what is the unit of kinematic viscosity? So it is option A, meter square per second. So what is Newton second per meter square? It is the unit of dynamic viscosity. Many of us get confused with this because we are studying both, right? Meter square per second and Newton second per meter square, and we get confused. So remember, the unit of dynamic viscosity is Newton second per meter square, and it is also known as, in CGS it is known as poise. On the other hand, the unit of kinematic viscosity is meter square per second, and the CGS unit is centimeter square per second, and it is known as Stokes. Okay, so Ashwin has got it wrong, and many of us has deleted the messages. I think they also have gone wrong. Okay, so just understand, right? There will be a difference and we will get confused. Okay. So it was asked in 2018. Shall we move to the third question? Okay. So question number 4. Okay, so it is related to buoyancy, 2017 ISRO. A body floating in water is said to be in neutral equilibrium if its meta-center. That is the question. Okay, and you are having 4 options. It coincides with the center of gravity. It lies above center of gravity. It lies below center of gravity. It lies between center of buoyancy and center of gravity. So what is the condition for neutral equilibrium for a floating body? Okay, many have said the answer. Let's see what is the right answer. So it is option A. Okay, all of us have said option A. Okay, so when the meta-center coincides with the center of gravity, we can say that the body is in neutral equilibrium. Which body? It is your floating body. Okay, so first of all, let's see what a meta-center actually means. Okay, so when a floating body is given a small tilt from one side or from the other side, whichever side, okay, it will oscillate, or it will start oscillate. This point about which a floating body starts oscillating is known as meta-center. This point is known as meta-center. Okay, so meta-center can be above or below or at the same point for a floating body. Okay, so if the meta-center is above center of gravity, it is the stable equilibrium. It is the stable equilibrium of a floating body. It is the stable equilibrium of a floating body. You only have to study this. Then think, if this is the stable equilibrium, what will be unstable? When m is below g, right? Then what will be the neutral equilibrium? When g and m are on the same point. So if you study all the 3 cases, you will get confused. It is better to study only one case. When the meta-center is above center of gravity, the floating body is in stable equilibrium. Then it is better to think, what is if it is below? It is unstable. If it is on the same point or when it coincides, it will be on the neutral equilibrium. Okay, what was our question? Our question was when the floating body in neutral equilibrium and the meta-center, so it coincides with the center of gravity. One more thing, the distance between it will be the next question. Okay, the distance between center of gravity and metacentric is known as metacentric height. Okay, GM can be written as, it is known as metacentric height. So if your metacentric height is positive, we can say that the body is in stable equilibrium. So for unstable, it will be negative, and for neutral, it will be 0. They can also ask like that. Okay, so if the metacentric height is positive, the body is in stable equilibrium. Then think it is negative, it will be in unstable equilibrium, and if it is 0, it is in neutral equilibrium, right? Okay, so what is metacentric height? It is the distance between metacenter and center of gravity. Okay, so the next question is a similar one. 2019 ISRO, I have already said the answer, but you can just give it a try. The metacentric height is the distance between, what is metacentric height? Center of gravity of the floating body and center of buoyancy, center of gravity of the floating body and metacenter, metacenter and center of buoyancy, original center of buoyancy and new center of buoyancy. Okay, can you answer the question? Metacentric height. Yeah, as already said, it is the distance between the center of gravity of the floating body and the metacenter, right? Already said that. This was the distance between metacenter and center of gravity is known as the metacentric height. Okay, remember one more thing. For a submerged body, it is also having 3 types of equilibrium, namely stable, unstable and neutral. Okay, the stability condition for a submerged body is set based on the positions of B and G, where B is your center of buoyancy. So what actually center of buoyancy means is the point about which the buoyant force is supposed to act. So when a body comes in contact with a liquid, an upward force is exerted by the liquid on that body. That upward force is known as the the upward force is known as the buoyant force. The point about which the buoyant force is supposed to act is known as the center of buoyancy. So the center of buoyancy is above center of gravity. We can say that it is the stable equilibrium of a submerged body. Remember, okay, the stable equilibrium of a submerged body. So can you think what will be the unstable equilibrium? When center of buoyancy is below center of gravity, and when both are at the same point or when they coincide, we can say that that will be the neutral equilibrium of a submerged body. So don't get confused with submerged body and floating body, because it is easy, because we are studying both the cases, right? So we easily get confused and they will give options to confuse us. So don't get confused. One is the floating body, another is the submerged body. Okay, fine. So let's move on to the next question. Okay, so this is from open channel flow. Remember, when we look into the previous year questions, a majority of the portion questions from fluid mechanics has been asked from open channel flow. So you study open channel flow thoroughly, right? So when we take the number of questions, if there are 3 questions or 4 questions or 5 questions, the percentage of open channel flow in that is more than 50%. Okay, which means if we take 10 questions or 6 to 7 questions or 5 questions has been from open channel flow. Okay, so when we prepare for an ISRO exam, prepare open channel flow thoroughly. Okay, so this is a question you can try. It is asked in 2015. It is asked in 2015. Can you give it a try? The ratio of hydraulic radius of a pipe running full. The hydraulic radius we study actually in open channel flow, or it's the allowance comes in open channel flow, but the question here is about pipe. Okay, it is not the radius. Don't get confused that. Okay, it is the hydraulic radius. The ratio of hydraulic radius of a pipe running full to the hydraulic radius of a square section as a channel. Remember what is a channel? Channel does not have a top. The top will be open to the atmosphere. That is the meaning of a channel. Okay, so what is the ratio of hydraulic radius of a pipe running full to the hydraulic radius of a square section as a channel running full whose side is equal to the diameter of the pipe? Can you try? Just think hydraulic radius. I will explain. So hydraulic radius is what? Hydraulic radius, it is not radius. So one is a pipe running full. So we know that pipe is having a round shape. then the second one is square section as a channel, so it is not having a top surface, or the top surface is open to the atmosphere, and the side of the square channel is equal to the diameter of the pipe. Okay, that is the question. Okay, one or two has answered, others are just trying. Okay, let's see what will be the answer. Okay, the answer for this question is option D. Shruti has given us the answer, Shibina has also said D. Okay, let's see what is hydraulic radius actually means. Okay, so hydraulic radius, or it can also be said as hydraulic mean depth. It is a ratio of the wetted area to wetted perimeter. It is the ratio of wetted area to wetted perimeter. Means if a liquid comes and wet your surface, how much area is wet, cross-sectional area to the wetted perimeter is hydraulic radius, and it can be written as R. So R is the radius wetted area to wetted perimeter. What was our first situation? It was pipe, right? So pipe is running full. If the pipe is running full, what will be the wetted area? If d is the diameter, we can say that it is pi by 4 d square, right? The pipe is running full, so it is full of water. So all the area will be covered. So the wetted area is pi by 4 d square. And what will be the wetted perimeter? Since the pipe is having a circular cross section, we can say that the wetted perimeter is pi d, right? Pi d. So what will be R for the case of pipe? So it is pi by 4 d square divided by pi d, right? So when we cut pi and pi, d1 d and d square, we get d by 4. So this is the hydraulic radius for a pipe running full. What was our second situation? It was a channel, right? It was a square channel, right? The square channel. So for a square channel, the top surface is open, right? It will be having only 3 sides. Okay, so what will be the wetted area? So wetted cross-sectional area, there is no change, it is square, so it is d into d. What will be the wetted perimeter actually? It is 3d, not 4d. Why? Because the top surface is open, right? So you will be having 3 sides. This is your channel. So 1d, 2d, 3d. So you will be having only 3 times d. So when we divide this, we get what? D by 3, right? D by 3. So we need the ratio of R of the pipe to that of the square section, right? So when we divide both, we get, we get d by 4 divided by d by 3. What will be the answer? Can you say? What will be the answer? D by 4 divided by d by 3. D by 4 divided by d by 3. Are you getting? Yeah, it is 3 by 4. Clear? Okay. So channel means the top surface is open. So only having 3 sides. So you got it, 3 by 4. So what will be the answer for this question? The answer is option D, 3 by 4. Right? Understood? Okay. So similar question has been asked one more time in 2019. Right? So if you understand the concept of the previous question, you can simply solve this question. Just simply solve this question. The hydraulic radius, again this is hydraulic radius of a circular pipe of running full and having a diameter of 300 mm. Simple question. If you understand the previous question, it is very, very simple. Within seconds you can write, within seconds. Please comment your answer on the chat box, okay? Then we can understood how many has got the correct answer, okay? It's not an issue if you get wrong, right? We are here to study. So just understand the concept, it will be a better idea, okay? Rather than getting confused if I am getting wrong, it is not an issue, okay? Just comment the answer what you are getting. Okay, everyone is said B. Okay, simple it is. What is hydraulic radius? We already said that. Hydraulic radius R is D by 4, right? So it is 300 is your diameter. It is running full. It is full. It is running full. So it is 300 divided by 4. So he is getting simply 75 mm. Okay, so the answer is option B. The answer is option B, 75 mm. Okay, so similar questions has been asked for many exams. So once you understand one concept, you can easily implement that in further questions. Okay, so we are moving on to the next question. Okay, so this is also a problematic area, a trapezoidal channel. So here there are two questions or two unknowns. Okay, so if it is having two unknowns, it is also asked in 2018 ISRO exam. If there are two unknowns, just think if finding one answer will get you the correct option. If not, you have to find both the answers. But in a similar way, or to save time, it is better to think finding one answer will give the correct option. If so, you can think like that. Okay, so a trapezoidal channel has a bottom width of 6 meter and a side slope of 1:1. The depth of flow is 1.5 meter and the discharge is 15 cumex. The hydraulic radius and the hydraulic depth of the flow is, the hydraulic radius and hydraulic depth of the flow is. Hydraulic radius and hydraulic depth. So already hydraulic radius we have discussed. So can you just think hydraulic diameter, or simply finding hydraulic radius will be a good idea because you get an answer, because all the four options are different. When we see about hydraulic radius, if there are two data to be found out, the first one will be the first one asked, like hydraulic radius will be the first one, okay, and the hydraulic depth will be the second one. Okay, so when we see hydraulic radius, all the four options are different. Again hydraulic depth, all the four options are different. So finding one will be enough to get the correct answer. Okay, you can use the calculator because until 2019 calculators were allowed for the exam, scientific calculators, and 2020 the exam was online. So online you also get the online calculator. Okay, so many of the questions you require calculator for doing, so you can use the calculator if required, right? Okay, but we don't know what will be the situation in 2023 because only you can be able to know once the whole ticket will be issued. Okay, so for this question calculator was allowed because in 2018, so calculators was allowed, so if you can use the calculator. Okay. So when we refer the many of the previous year questions, many of the questions require calculator for doing, especially in fluid mechanics area, because there was a square was required, a cube root, fifth power, similar questions were asked. Okay, so if required you can use the calculator until 2019. 2020 the exam was conducted online, so calculator was provided in the system itself, and 2023 what is going to happen, only when the whole ticket arrive you will be able to know. Okay, okay, two has answered option A and option A. What's happening to others? Others are doing, just give it a try. Okay, because we know what is hydraulic radius or how to find the hydraulic radius. Give it a try. If it is a trapezoidal channel, just draw the figure how it will be a trapezoidal channel. Okay. Hydraulic radius was the ratio of your wetted area to wetted perimeter. So how can it is possible, wetted area by wetted perimeter? So it is a trapezoidal channel. The slope is given 1:1. The slope is given 1:1. So for 1:1 slope, how will it be for a trapezoidal channel? The depth of flow is also given as 1.5 meter. The discharge, if required, you can use it. The hydraulic radius and hydraulic depth of flow, both has been asked. Okay, so only two are answering. So let's see what will be the answer. The answer is option A. Okay, Abhinay has said the correct answer. Shivina also has said option A. Okay, so let's see how to approach this question. So there is a trapezoid channel having a bottom width of 6 meter and the slope is 1:1. Okay, so I am having a trapezoidal channel, right? So this is the trapezoidal channel. Okay, it is having bottom width of 6 meter and the slope is 1:1, which means it is 1 horizontal to 1 vertical. The horizontal is 1, the vertical is also 1, right? So we don't know what is here the top width or the depth of flow, sorry, top width we don't know. We know the depth of flow, right? The depth of flow is given us 1.5 meter. 1.5 meter. So if this bottom width is 6 meter, we can say that this area, like this portion will also be having 6 meter, right? This is also having 6 meter. Then what about this and what about this? So the slope is 1:1. So if this depth is 1.5 meter, what will be this portion? This portion will also be 1.5 meter. Okay, similarly this is also having a slope 1:1. So if this is also 1:1, then here it is also 1.5 meter. So what will be your top width? It is 6 plus 3, 9 meter and your bottom width is 6 meter and your depth is 1.5 meter. Okay, then in the question it has been asked two things. First one was their hydraulic radius and the second one is hydraulic depth. Both are different. Okay, so hydraulic radius we already understood, it is the ratio of the wetted area to wetted perimeter. Okay, so what will be the wetted area? It's a trapezoid, right? So the wetted area we can write it, there are many ways to find the area of the trapezoid. We can simply write half h into a plus b. This is a common formula. So where half h is the distance between the parallel sides, so it is 1.5. Then a and b are your parallel sides, which are 6 plus 9. So you can find the wetted area using this. Then what about wetted perimeter? What about wetted perimeter? So wetted perimeter is, it is 6 plus. If this is 1.5, this is 1.5, what will be this side? What will be this here? 1.5 square plus 1.5 square. This is on the one side, other side also same. Okay, so we can write it, it is plus 2 into root of 1.5 square plus 1.5 square. Okay, so you get the wetted perimeter, you get wetted perimeter. So once you divide wetted area by wetted perimeter, you get the hydraulic radius is 1.09 meter. Okay, fine. In the question it has also asked what about hydraulic depth, right? So hydraulic depth or hydraulic diameter. Remember, hydraulic depth or hydraulic diameter is hydraulic depth or hydraulic diameter or hydraulic diameter. It is a ratio of wetted area to top width. It is a ratio of wetted area to top width, which means how much area it has been wet divided by the top width ratio will give the hydraulic diameter or the hydraulic depth. It can be written as capital D. So in the figure, what is the wetted area? Already we got it, right? 1 by 2 into 1.5 into 6 plus 9. And what will be top width? It is 9. Okay, so we can write it is equal to 1 by 2 into 1.5 into 9 plus 6, right? Divide by 9. Okay, so it is 1 by 2 into 1.5 can be written as 3 by 2 into 15 divided by 9. Okay, so we can strike this and this, it is 3, then this and this, it is 5. So it is 5 by 4, which you will get simply as 1.25. Okay, so it is simple to find hydraulic diameter or hydraulic depth. So when we see the option, we get 1.25 in a much easier way, right? So when we look at the options, it is option A, 1.098 meter and 1.25 meter. So which is better, you can find in that way. If finding hydraulic diameter is an easier way or hydraulic depth is an easier way, you can go for that. If it is the other one, you can go for that. So simply finding one will be equal. Okay, Bini has said another formula also, you can use that also. Okay, so there are many ways for finding the area, that's not an issue, right? So option A is the answer. Okay, you get an answer, option A. Okay, so hydraulic radius and hydraulic depth or diameter has been asked for several exams or several previous year exams. So please keep that in mind. Okay, when we study thoroughly hydraulic radius and hydraulic depth. Okay, so let's move on to the next question. Okay, so it is also from an open channel flow. It is a theory question. You can easily answer it. In open channels, specific energy is. So what is specific energy in open channels? We are having 4 options. Option A is total energy per unit weight. Option B, total energy measured with respect to datum passing through the bottom of the channel. Option C, total energy measured above horizontal datum. And option D, kinetic energy plotted above free surface of water. These are the 4 options for this question. The question is, in open channels, what is the specific energy, or what is the definition for specific energy? Just give it a try, you will be able to answer it. Total energy per unit weight, total energy per unit discharge, total energy measured with respect to datum passing through the bottom of the channel, total energy measured above the horizontal datum, kinetic energy plotted above free surface of water. These are the questions. Okay, let us see what will be the answer. Okay, the answer is option B. All of us had said the correct answer. Okay, so what about what actually is specific energy? Let's see. So in open channel means the flow through the river or the channel can be easily said as open channel, right? So this is the channel bed. Let us consider this as the channel bed, and above it liquid is flowing. So let this be the high water surface. Okay, so this is water surface, and we can consider any datum. Okay, datum is any point of known elevation. Okay, so this distance is Z and this distance is Y, where Y is your depth of flow. Okay, so when we consider any section in an open channel flow, the total energy per unit weight, in an open channel flow, the total energy per unit weight is given as Y plus V square by 2G plus Z. Okay, so in any open channel flow, the total energy per unit weight is given as Y plus V square by 2G plus Z. Okay, so if the channel bed itself is taken as datum, it has not been said anywhere that the reference line or the datum must be horizontal. It can be any line. It can be horizontal, it can be inclined, it can be vertical also. Okay, so if the channel bed itself is taken as datum, what happens? If the channel bed itself is taken as datum, what happens? There will not be any Z, right? So if the channel bed is taken as datum, then the corresponding total energy per unit weight will be, Y plus V square by 2G. This is known as specific energy. So what actually is the specific energy? It is the total energy per unit weight with the channel bed as datum. The total energy per unit weight with the channel bed as datum, and the equation is Y plus V square by 2G. Remember one more thing also, even though it is the energy or it is a specific energy, don't get confused with the unit. Okay, the specific, even though it is said as specific energy, the actual thing is total energy per unit weight, and hence the unit of specific energy is meters. Specific energy unit is meters. This also being asked for several exams. We always get confused with that. Okay, so even though it is energy, don't go for joules or erg. Okay, so even though it is specific energy or the energy term is there, it is simply the total energy per unit weight with the channel bed as datum. So when we consider, the unit is in meters. Okay, so the answer for this question we can say as it is option B, is the total energy measured with respect to the datum passing through the bottom of the channel. Clear? Okay. So similar question, again it is also about specific energy. It is again a theory question. When the water in a channel is flowing at critical velocity, the ISRO 2019 question. Option A, specific energy will be maximum. Option B, specific energy will be minimum. Option C, critical depth will be 0. And option D, none of this. Okay. This simple theory question is always related to specific energy. Previous question also it was related to specific energy. Okay. So what actually is critical velocity? Like what happens when a flow reaches the critical velocity? Specific energy will be maximum, specific energy will be minimum, the critical depth will be 0 or none of the above. Got the answer? Okay, the answer is specific energy will be minimum. So let's see what actually is the concept behind this. Okay, so in the previous question we said that specific energy, it is denoted by letter E, right? It is denoted by the letter capital E. It is E is equal to Y plus V square by 2G. Okay. The flow when your specific energy is minimum, when the specific energy is minimum, the corresponding flow is known as critical flow. Critical flow also has another definition also. For in case of specific energy, the flow corresponding to minimum specific energy can be defined as critical flow. Okay. If the flow is critical, the corresponding velocity is known as critical velocity. The corresponding velocity is known as critical velocity. So we can say that the energy minimum, if the specific energy is minimum, the corresponding velocity is known as critical velocity, and if the corresponding depth is known as critical depth. So it is the depth corresponding to minimum specific energy. The depth corresponding to minimum specific energy is known as critical depth. The velocity is known as critical velocity and the flow is known as critical flow. There are equations for critical depth. If we consider a rectangular channel with the dimensions b and y, the critical depth yc is q square by g the whole raised to 1 by 3. If we consider, remember this is only for a rectangular channel, okay. If we consider a rectangular channel with the dimensions b and y as depth of flow, the equation for critical depth is yc is equal to q square by g the whole raised to 1 by 3, where q is the discharge per unit width. Q is not the discharge, it is the discharge per unit width. Okay. So when the specific energy is minimum, the corresponding flow, corresponding depth, critical depth, and the corresponding velocity is critical velocity. Okay. Other than the given E value, when we consider any E values, so for minimum specific energy will be having critical depth. Other than this minimum value, when we consider any values, we will be having two depths for a given specific energy. That depth are known as alternate depths. That depth are known as alternate depths. Remember, okay. So other than E minimum, when we consider the specific energy for any point, for a given specific energy, I will be having two depths. One will be above the critical depth and one will be below the critical depth, and they are together known as alternate depth. Or simply we can say like this: at alternate depth, the specific energy is a constant. At alternate depth, the specific energy will be a constant. Okay. So these are the things you have to remember from this area. Okay. Let's move on to the next question. So this is about match the following question. So there are group A and group B. Group A, there are 4 numbers: Reynolds, Fruits, Weber and Euler. Group B is their corresponding definitions. So can you write? I also can give the options, but it is on the other slide because it's a lengthy question. So that's why it is in 2 parts. This is the option, okay. A, B, C, D, this is the option. So both cannot be put on the same slide. That's why it is on 2 slides. Okay. Okay, let's see what is the answer. Okay, so in fluid mechanics mainly we are dealing with 5 dimensionless numbers. Okay, you have to understood each numbers because question has been asked frequently about the dimensionless numbers. So we are having 5 dimensionless numbers. They are this. These are all the first letters of the corresponding numbers we have to study. R stands for Reynolds, F is fruits, E is Euler, W is Weber, and M is Mach number. Remember, for all these numbers, the numerator, so it is a ratio of 2 forces, all these numbers are the ratio of 2 forces, the numerator is inertia force. For all these numbers, the numerator is inertia force. Then the denominator number changes, corresponding we get so for all these numbers, the numerator is always inertia force. The corresponding denominator, the forces will be different, and the corresponding we will get the numbers. The ratio of inertia force to viscous force will be Reynolds number. The ratio of inertia force to gravitation force will be Fruit's number. The ratio of inertia force to pressure force will be Euler's number. The ratio of inertia force to surface tension will be Weber number, and the ratio of inertia force to elastic force will be Mach number. Okay, so R stands for Reynolds, F stands for Fruits, E stands for Euler, W stands for Weber, and M stands for Mach. The ratio of inertia force to viscous force is Reynolds, inertia to gravity is Fruits, inertia to pressure is Euler, inertia to surface tension is Weber, and inertia to elastic force is Mach number. Okay, so here let's see what are the options. Okay, so what is Reynolds number? Sorry. So Reynolds number, ratio of inertia to surface tension, inertia to pressure, inertia to viscous. So this is AC. Okay. What about Fruit's number? Fruit's number is the ratio of inertia force to gravitational force. So B is D. What about Weber number and Euler's number? So Weber number, what we can say Weber number? Weber number is surface tension, right? So Weber number. Weber number is the surface tension, and the Euler's number is then the only remaining thing is the pressure force. Okay, so this is the way. So you can apply any method for studying all these dimensionless numbers. So remember one thing, for all these 5 numbers, whether it is Reynolds, Fruits, Euler, Weber or Mach, the numerator is always the inertia force. Then the force in the denominator part changes and the corresponding numbers are obtained. Okay, because it is easy to study in that way, because if we blindly study this is the ratio of this, we get confused. So understand, for all these 5 numbers, the numerator is always the inertia force and the corresponding denominator number changes and we get the required number. Okay, similar 1-2 questions has been asked for the previous exam. This is 2014, right? This is ISRO 2014. Similar question was asked for 2014 ISRO exam again. It is about Mach number. When Mach number is less than 1, the flow is cold. When Mach number, it is easy, you can simply answer it. When Mach number is less than 1, the corresponding flow is known as. You can say in seconds, right? Just 2 seconds. What happens when Mach number is less than 1? Yeah, simple. The answer is subsonic. So remember, this classification or this criteria is for only for aerodynamics. Aerodynamic study. Okay. This number or this classification is for aerodynamic study. Okay, not for pipe flow or something like that. Mainly used for aerodynamics, which means when the speed of sound or light something. Okay, so aerodynamic study we use this Mach number. So when Mach number value, if M is denoted as Mach number, if Mach number is less than 1, the flow is termed as subsonic. So then you can think, what about sonic? Sonic, the Mach number will be equal to 1. What about supersonic? The Mach number is greater than 1, it is supersonic, and when the Mach number value become greater than 5, when the Mach number value become greater than 5, it is known as hypersonic. Remember these two things, sometimes we get confused. these two. Okay, supersonic and hypersonic. So which is larger? Think. Supersonic is when Mach number is greater than 1 and hypersonic is when Mach number greater than 5. Okay, so this is only for aerodynamics testing or aerodynamic study. Remember, okay. Let's move on to the next question. Similar question has been asked once more time. In 2018, Weber number is the ratio of inertia force to. So see, the one area they have been concentrated questions has been asked. Okay, so Weber number is the ratio of inertia force to what? Give it a try. So already we have discussed a similar question. It is the ratio of inertia force to surface tension. Okay, so 5 numbers. Don't forget inertia corresponding all this numerator, then Reynolds, Fruits, Weber, Euler, Mach, the denominator number changes. Okay, then it is an instrument. You are all familiar with this instrument, pitted tube. It is asked for ISRO 2017. ISRO 2017. What actually pitted tube is used for? The options are velocity of flow required at a point. Option B, pressure difference between 2 points in a pipe. Option C, total pressure of the liquid flowing through a pipe. Option D, discharge through the pipe. Okay, I think everybody knows the answer. Okay, the answer is velocity of flow required at a point. Okay, so pitted tube, Venturi meter and orifice meter are the applications of Bernoulli's equation. So what is Bernoulli's equation? Bernoulli's equation states that the total energy, or it is based on law of conservation of energy, the total energy per unit weight at any point is a constant. There are certain assumptions. The fluid must be ideal, irrotational, steady, all these are incompressible, all these assumptions. So based on these assumptions, he states that the total energy per unit weight in a flow, for an ideal fluid, is constant. Based on this law or this principle, there are 3 instruments mainly. They are pitted tube, Venturi meter and orifice meter. In that, pitted tube is mainly used for finding the velocity of flow, and Venturi meter and orifice meters are used for finding the discharge through pipe. Okay, so let's see an image of pitted tube. Venturi meter. So this is a Venturi meter. A Venturi meter will be having 3 main parts. You can see that there will be a converging part, there will be a throat, and there will be a diverging part. When we compare the lengths of converging part and diverging part, it is larger, which means the diverging part is larger than the converging part, and the throat is the one having the minimum area. Okay, it is also uses the principle of continuity equation. Okay, so don't think that the Bernoulli's equation is only the application of Venturi meter is only the application of Bernoulli's equation. We can use both Bernoulli's equation as well as continuity equation, but the majority of the part is served by the Bernoulli's equation. Okay, so this is a pictorial representation. We can see that this is the converging section, which is smaller in length compared to the diverging section. The one which is having the minimum cross-sectional area is known as the throat, and we apply Bernoulli's equation at both the section, which means at section 1 and section 2. So for this we have to require, or the Bernoulli's equation, when we apply section 1, if we consider this as section 1 and this is section 2, these are the section 1s and 2s, then the corresponding U2 manometer is required for joining the sections to find the difference in pressure. Okay, U2 manometer is required for finding the difference in pressure. So what actually Bernoulli's equation states that when the flow occurs, the total energy at section 1 and section 2 will be same. That is actually the Bernoulli's equation. So if we consider 1 and 2, it is simply said that P1 by rho g plus V1 square divided by 2g plus Z1, Z1 is the datum, that is equal to P2 by rho g plus V2 square divided by 2g plus Z2. This actually is the Bernoulli's equation, but this is based on many of assumptions. But in actual situation, this is not the real case, because when the flow occurs from one point to another, there will be some energy loss. Like, because when actual case there is viscosity, and when viscosity comes, there will be friction and there will be loss. But this equation is derived based on the assumption that the fluid is ideal. So there is no viscosity, and hence we can say that section 1 and section 2 the total energy is same. So by applying this condition, we find a result for finding the discharge. The discharge is found out using Bernoulli's equation. But the actual discharge, or we can say that this equation will be the theoretical discharge, because based on the Bernoulli's assumption, you said that the flow is ideal. But when we consider the actual liquid case, when we consider actual situation, the discharge will be slightly lesser than this value. For this purpose, we introduce a correction factor or a hydraulic coefficient known as CD. C suffix capital, sorry, small d. It is known as coefficient of discharge. It is known as coefficient of discharge. So what actually coefficient of discharge means? It is simply the ratio of theoretical discharge to actual discharge. Sorry, the ratio of actual discharge to theoretical discharge. Okay, so CD is simply the ratio of what is your actual discharge to theoretical discharge, and the value of CD will always be less than 1. Even though there are certain instruments with the CD value 1, in majority of the cases the value of CD will always be less than 1. Okay, for a venturi meter, the general value taken is 0.98. For venturi meter, the general value of CD taken is 0.98. It varies depending on the type of instrument you are using. For every discharge measuring instrument, they will be having their own CD values. For venturi meter, it is 0.98 is the upper limit, or we can say if we require a range, we can say that it is between 0.95 to 0.98. Then again, it is a range value, so that varies from textbook to textbook. Okay, so it is better you study an accepted value of 0.98. Okay, there are one more instrument that studies the discharge, or that measures the discharge. It is the orifice meter. So this actually is the orifice meter. It is also known as orifice plate. So this is the orifice plate. This is the pipe that is flowing. This is the schematic representative. There is also, it is having a differential manometer. We will be having a differential manometer. This is the direction of flow. Again, section 1 is there, section 2 is there. We apply Bernoulli's equation and we find the equation for discharge. In that also there will be having CD, because for all the instrument that measures discharge will be having a correction factor or a coefficient of discharge. For this orifice meter, the value of CD ranges from 0.6 to 0.7. Okay, so it is slightly lesser value compared to venturi meter. Sometimes question can ask like what is the range, or which is having a higher CD value, like that. Okay, so remember CD is the range is between 0.6 to 0.7. Okay, so for this question, the actual answer is velocity of flow required at a point. If the question was discharge through the pipe, it can be venturi meter or orifice meter. If the pressure difference is required, you need differential manometer, and for finding the total pressure, you need, depends what if you require the pressure at a point, you need simple manometers like piezometer or single column manometer or U2 manometers. That will be discussed in the later question. Okay. Okay, say again it is asking 2017, again it is a theory question, you can write that. The pressure of liquid measured with the help of piezometer tube is, sorry, this is actual question, sorry. The pressure of liquid measured with the help of piezometer tube is. What actually a piezometer tube can measure? Vacuum pressure, atmospheric pressure, absolute pressure, gauge pressure. So if you have to write the answer, you first know what actually all these pressures means. Once you know what actually these pressures means, you can easily write the answer. Okay, the question is, the pressure of liquid measured with the help of a piezometer tube is. So what actually is a piezometer? It is a simplest form of manometer. What are the different types of pressures? There is a vacuum pressure, there is atmospheric pressure, there is absolute pressure, there is gauge pressure. What actually it means? So we all have to know these all areas to answer this question, but you can, if you have studied manometer topic, you can easily answer the question. Okay, just give it a try. It is a theory question. Okay. Problems of manometer has also been asked for exams. Okay, so you have to study manometer area also thoroughly. Okay, so Binay has answered, Nayana has answered, Shibina also answered. Both are all are saying option D. Others are not answering. Okay, Vaishnav also said D. Okay, let's see what is the answer. The answer is option D, gauge pressure. Okay, so what actually are these types of pressure? Let's see first. Okay, so pressures can be classified into 4 categories, or we can say that it is classified into 3 categories. They are absolute pressure, gauge pressure and vacuum pressure. Okay, we can study this concept by understanding a simple graph. Okay, so in a x-axis I am giving absolute 0 or absolute vacuum. Absolute 0 can be Z or absolute vacuum can be Z. In y-axis we are saying that pressure P is in y-axis. Okay, in between I am considering a line like this. This is the atmospheric pressure. I am considering 2 points, point A and point B. These are my 2 points. Okay, the pressure that is measured with reference to absolute 0. The pressure that is measured with reference to absolute 0 is called absolute pressure. So then the question arises, what actually is absolute 0? Okay, simple as it is. You are sitting in your room, right? If all the air, or we can say that you are experiencing some pressure due to the air inside your room. Okay, if all the air in that room is removed, all the mass of air in that air is removed, that situation is known as absolute 0 or absolute vacuum. Okay, simply you are sitting in your room or a studio or in your hall, whatever it is, you are experiencing some pressure due to the air around you. Okay, if all the mass of air that is surrounding you is completely removed, that stage is known as absolute 0 or absolute vacuum. With that taken as reference, the pressures that is measured is known as absolute pressure. The pressure that is measured with reference to absolute 0 is known as absolute pressure. So in that scenario, we can say that absolute 0, this, okay. So this is the absolute pressure. This is absolute pressure of A. Similarly, absolute 0, this is the absolute pressure of B. So these are the absolute pressure of both A and B. Both A and B. Okay. And what actually is gauge pressure? Gauge pressure and vacuum pressure are measured with reference to atmospheric pressure. Okay. So atmospheric pressure taken as a reference, the value that is measured above it. Any pressure that is measured with reference to atmospheric pressure and above it is always known as gauge pressure. Gauge pressure, and hence it is also known as positive pressure. Okay. Then the pressure that is measured with reference to atmospheric pressure and below it. The pressure that is measured with reference to atmospheric pressure and below it is known as vacuum pressure. So we can say that this is the vacuum pressure. So this is your gauge pressure and this is your vacuum pressure. Okay. Both the reference is atmospheric pressure, and for absolute pressure the reference is absolute 0 pressure. What is absolute 0 pressure? If a container or a closed vessel is taken, if all the air is removed, all the mass of air is removed from that container, that situation is known as absolute 0. Okay. Now, let us see what actually is the relation between gauge pressure, atmospheric pressure and absolute pressure. In this figure, we can see that from here is absolute. From here to here it is atmospheric, and from here to here it is gauge. So we can easily write as P absolute is equal to the sum of P atmosphere plus P gauge. To the sum of P atmosphere plus P gauge. Okay. Similarly, what about P absolute, P vacuum and P atmosphere? So when we consider B, from here to here, this is atmospheric pressure. Okay. From here to here it is absolute pressure, and this is the vacuum pressure. So we can say that P absolute is equal to P atmosphere minus P vacuum. Okay, P atmosphere minus P vacuum. These are the two equations you need to understand. Simply understand this graph, you can easily able to write these equations. Sometimes problem can be asked from this. Okay, so this actually is the types of pressure we need to understand, that is gauge, vacuum, absolute and atmosphere. Then what about the next thing we have to understand? What actually is a piezometer? Okay, so there are a lot of pressure measuring instruments, but for an exam point of view, we mainly study about manometer. Manometer, there are of two types. One is simple manometer and the other is differential manometer. So manometer, we can classify that into two. Manometer. One is simple and the other one is differential. So as the name suggests, simple manometer is only used for finding the pressure at a point. If you require the pressure at a given point, so there is a point A or there is a point B or there is a point Z. If you require that pressure at that point, you can use simple manometers. And if you need the difference in pressure between 2 points, if you knew it, the difference in pressure between 2 points, say I am having 2 points, A and Z. I need the difference between A and B, you can use differential manometer. Okay, so either they will give the difference between PA minus PZ or it is PZ minus PA. It will not give the pressure at a given point. Understand? A differential manometer can give the difference in pressure between 2 points, whether the 2 points are on the same pipe or different pipe. It does not give the pressure at a given point. The thing is, so if I use a differential manometer, I get the value of PA minus PB as simple example. Okay, it is 20 kilopascal. So this 20 kilopascal can be 30 minus 10, right? It can be 40 minus 20 or even it can be 45 minus 25. This value it will not give. It simply give the difference between 2 points. If you are point A and if you are point B, I will give the difference between 2 points, but I cannot give each point the particular value. That is the differential manometer. Okay, in simple manometer it can be further classified into 3. The one is piezometer. The one is piezometer. And the second one is U-tube manometer. U-tube manometer spelling is not the common thing you are using for this class. It is U-tube manometer. And the third one is single column manometer. It is single. It is single column manometer. Okay. So piezometer is the most simplest form of manometer. It is the most simplest form of manometer and it can measure only gauge pressure up to moderate values or medium values. Piezometer is the simplest form of manometer. It can measure gauge pressure up to moderate values only, which means it cannot be able to measure high gauge pressures. High gauge pressure it cannot be able to measure. It can measure up to gauge values, only gauge values which is above atmospheric pressure at the moderate values or medium values. It cannot be able to measure high pressure, high gauge pressures. A U-tube manometer can measure both gauge and vacuum. Remember, it can be asked. A U-tube manometer can measure both gauge pressure as well as vacuum pressure. Okay, single column manometer is the modified form of U-tube manometer. When the requirement is accuracy, it can be used. Okay, then differential manometer is of 2 types. It is U-tube differential manometer or it is inverted U-tube differential manometer. They both are the 2 different types of differential manometers. Okay, so for this question it was asked that a piezometer is used for finding, right? So a piezometer is used for finding the simplest form of manometer. It can only measure the gauge pressure. So the answer for this question is option D. So understand the theory that is behind this question. You have to understand the type of pressure. Also you have to understand the type of manometers. Clear? Okay. Okay. So let's move to the next question. Okay. So there is a problem that is asked in ISRO 2017. You can give it a try. It is not a difficult question, but you may require calculator. Just give it a try. So a pipeline of 300 mm diameter carrying water at an average velocity of 5 meter per second branches into 2 pipes of 150 mm and 200 mm. The total flow rate of discharge, it is not, it's total flow rate or discharge, okay, both are same actually. The total flow rate or discharge of the water in the system is, the datas, all the datas are not required for this solution, okay. You can easily find with one data enough or 2 datas are enough, okay. Just to manipulate you, they have been given that the branches into two pipes of diameters dash and dash. Okay, simply you can require two data for finding the answer, and you can use the calculator for finding. Okay, because then the area is required, there is a pi. Okay, so just give it a try. Option A is 58 liters per second. Option B is 132 liters per second. Option C 353 liters per second, and option D is 832 liters per second. Nobody is getting the question. Don't think it is a difficult question. Okay, it is a simple question. It is very simple question. You know the concept, you know. I can give one clue. It is simply based on the continuity equation. Simple as it is. I need the discharge. And you are having diameter and the corresponding velocity. So just the branching is not required actually. It is just to confuse you that the data are given like that. Okay. Okay. So let's see the answer. Okay. So the answer is option C. Swati has said, Anaga, Shibina 9 all has said option C. Yeah, it is the right answer. Okay. So let's see. A pipeline of 300 mm diameter. Okay. So I am having a pipe. It is having a diameter of 300 mm. Whatever it is. It is 300 mm. And the velocity is given as how much? It is 5 meter per second, right? So the velocity is 5 meter per second. So this is the velocity 5 meter per second. It branches into two pipes. Okay. It branches into two pipes. Okay. With the diameter, I think it is one is 150 mm and the other is 200 mm. Okay. What is actually the discharge? Okay. So as per the continuity equation, we can say that the discharge will be same. So if here there are two branches, 150 mm and 200 mm, we don't know the velocity, so it is not required. Just think just before this area. Think before this area. So if you know the diameter of this pipe and the velocity, discharge, you all know what is discharge. What is discharge? What actually is discharge? It is, when we define discharge, it is the ratio of, or we can say that the quantity of water per or the liquid per unit time. But if we know the cross-sectional area and the velocity, what actually is discharge? What actually is? It is the product of area into velocity. Simple as it is. It is the product of area into velocity. You know the area, right? So it is, if it you are converting it to meter per second, it is pi by 4 into 300 into 10 raised to minus 3 square. This is the area. Into what is the velocity? It is 5. So you get, I think it's 0.353 meter cube per second. Okay, but the option, it is not meter cube per second, it is liters per second, right? So understand one thing. 1000 centimeter cube is 1 liter and 1000 liter is 1 meter cube. Okay, if you don't know, you can write in the side. 1000 centimeter cube is 1 liter and 1000 liter is 1 meter cube. Okay, so here it is 0.353 meter cube per second. Simply multiply by 1000, you get a good answer as 353 meter cube per second. Sorry, 353 liters per second. Okay, so the answer is option C. Okay. I think you are clear with this. Shall we move to the next question? Okay. So next question. Again, it is a problem about manometers. Okay, it is a bit lengthy problem. It is a bit conceptual problem. But once you understand the situation and once you draw the diagram, you can easily solve that. It was asked for the last time the ISRO conducted the scientist exam, which means it was asked in ISRO 2020. Okay, so it is a good question actually. Just give it a try. There is no diagram or nothing like that. So a pipe contains oil of specific gravity 0.9. A differential manometer connected at 2 points A and B shows a difference in mercury level of 15 centimeter. The difference of pressure at points A and B will be. You have to think to solve this question. If possible, you can draw the diagram. Okay, let's see how to do. Others are not, others are trying actually. Okay, Kibini has also given. Okay, let's see what the option is. The answer is option A. Okay, so what actually is the concept behind this? Let's see. So there is a pipe. Okay, there is a pipe. I just draw it in the. There is a pipe. Okay, a liquid of specific gravity 0.9 is flowing. Okay, S is equal to 0.9. Okay, there are 2 points A and B, and these 2 points are connected. There is an opening will be here. There is an opening will be here. The 2 points is connected by a manometer, a U-tube differential manometer, because there are 2 points. So we can find only the difference. So if it is A and if it is B, there is a U-tube manometer. Okay, and mercury is given in the manometer, and if not said, you can think as mercury, and the difference in level, is given by 15 centimeter. So the difference is given by, the difference in mercury level is given by 15 centimeter, or we can, if we convert into meter, is 0.15 meter. Okay, simple as it is. Okay, so for analyzing this type of questions, there are formulas also, or there are a concept also. Okay, so there is a formula we can see that where H is equal to X into Sm by Sp minus 1. We can use this equation where M is the specific gravity of the manometric fluid, P is the specific gravity of the fluid in the pipe, minus 1. Then you have to convert that into the unit, because here the unit of H will be in meters. So corresponding you have to convert that into, you get that answer. And more simpler way or more easy way to understand is like this. So this is also a formula that you can use. Okay, once you understand this concept, it will be easier to do that. Okay, so what actually we do is, we give a reference. The reference is simply the line which has the manometric fluid level the lowest. Okay, so the manometric fluid level the lowest is this thing. Okay, so this is taken as the reference, and you need only to think about that. The bottom is neglected. Okay, so let's say the different or the distance with this is y. Okay, you can go by anyway. The difference is y. Okay, and so we can say that this value is, what will be this value? This value is y minus 0.15, right? This value is y minus 0.5. So this is one limb and this is the second limb. So we can say this is the right limb and this is the left limb. So right limb and left limb. For the basic concept of manometries, the pressure in the right limb will be equal to the pressure in the left limb. So if this is taken as the left limb and this is taken as the right limb, P left, I'll change the ink, P left is equal to P right. Okay, P left is equal to P right. So when we consider the left, it is PA plus what actually going through this, liquid will enter in this portion, right? And this portion also, right? So the specific gravity is given as 0.9. The specific gravity is given as 0.9, and the formula for finding the pressure at a point is simply rho into G into H. Simply rho into G into H. So it is PA plus rho of liquid into G into that height is Y. Okay, this is one side. PA plus rho of liquid into G into Y is the one side, and that is equal to, on the right side, what actually is it? So it is this thing, this much we have to understand, okay, this much. So it is PB plus, for this portion it is the liquid that is having specific gravity 0.9, right? So it is rho of liquid into G into Y minus 0.15 plus, for this much portion it is mercury, right? So it is rho of mercury into G into 0.15. So P right, P left. You know the density of the liquid, because the density of the liquid is specific gravity is 0.9, so we can say that, I will write one more step, PA plus rho of the liquid is specific gravity is 0.9, so it is 0.9 into 10 raised to 3 into G into Y plus PB into, just open the bracket, 0.9 into G into Y minus, sorry, into 10 raised to 3 also there, 0.9 into G into 0.15 plus the mercury is 13,600 into G into 0.15. Okay, so what actually get cut off? This side 0.9 10 raised to 3 GY, this side also 0.9 10 raised to 3 GY. These both get striken off. So this both we can strike off. So simply what actually we require, it is PA minus PB or PB minus PA, whatever the actual, what is the difference in pressure between points A and B. Okay, so we require the difference in pressure between A and B. So we can say that PA minus PB actually is 13,600 into G into, what is that height, into 0.15 minus 0.9 into 10 raised to 3 into G into 0.15. This actually is the concept. So if you understand this concept, you get the answer as option A. I think it is 18. What actually is the answer? Let us see what the option is. It is 18,688. So the answer is 18,688 Newton per meter square. Okay, so you can solve this by understanding this concept. P right is equal to P left, or I said already said you can use the shortcut, or the equation is H is equal to x into Sm by Sp minus 1. Then you have to multiply with the corresponding liquid density, and then also you can solve the answer. Okay, so if you understand this concept, it will be used for any type of manometer. Most of the question will be asked about U2 manometer or U2 differential manometer, something like that. So if you understand this concept, once the right is equal to P left, you can give any values that get easily striken off, and thus you can solve that. You can only that this thing is there, right? Okay, I said this is plus, not this is plus, this is equal to, this is equal to. Okay, so PA plus rho 0.9 into 10 raised to 3 into G into Y, because 0.9 is specific gravity of the liquid flowing through the pipe, okay, is equal to PB plus, I expand this, so it is 0.9 into 10 to 3 into G into Y minus 0.9 into G into, here is out there is 10 to 3, sorry, minus 0.9 into G into 0.15 plus mercury, so it is 13,600 into G into 0.15. So these both get striken off. So only one side, it is PA minus PB is equal to this thing minus this, you will get the answer. This thing minus this, you will get the answer. So the answer is option A, 18,688. So this type of question has asked in the previous question, okay, 2020. So the level may get increase for the next time you are writing. So understand these type of questions. These type of questions will be useful because the cutoff is also increasing. I think in 2013 the cutoff was 140, 150 range. Now for the last time the cutoff was around 196, general category it is 195, which means out of 240, last time for each question the mark weightage was 3. For one question you will be getting 3 marks if it is correct, and if it is negative you will be getting deducting -1. Okay, so in that scenario the cutoff as 190. Okay, So almost you have to correct around 60 to 65 or 70 questions out of that 80. That means you can only leave 10 questions if all that questions are right. Okay, so that competition will always increase. So this type of questions will boost your rank if you understand this concept. Okay. Before moving to the next question, if you require to purchase some study material for this ISRO exam, there is a book available here. It contains all the previous year questions from 2013 to 2020, all the previous year questions with a detailed explanation. You can really helpful, or you can really use this question. The link for buying the question will be in this comment box, or you can also subscribe or purchase the ISRO test series. This is also useful. Okay, so both the comment, so both the link for buying this, it is in the comment box. You can use that for buying that. Okay, so let's move on to the next question. Okay, can I give it a try? So it is again from Bernoulli's equation. You can easily apply the concept. So these are problematic questions you need to understand, because earlier questions were the easier one, that is of theory, but when the problem comes, is your actual challenge. Okay, so there are 2 points, 1 and 2 in a pipeline. The velocities of fluid are V and 3V respectively. Both points are at the same elevation. The flow can be assumed to be incompressible, inviscoid, there is no viscosity, steady and rotational. The difference in the pressure P1 and P2 at point 1 and 2 is, and your options are given as option A 0.5 rho V square, option B 2 rho V square, option C 3 rho V square, and option D 4 rho V square. Just give it a try. Simply apply Bernoulli's equation on both the points and you will get the answer. Okay. Okay, Shivana has answered D, Fatima is D, Anaga it's D. Simple, very simple. Once you understand this concept, it is easy. Okay, this type of questions you must study well, because that boosts always your rank. Okay, and again there is an interview, that also is a matter. Okay, only 3 are getting answers. Option D by Shibina, Fatima and Anaga. Others are trying. Okay, let's see what actually is the answer is. Yeah, all of you are correct. The answer is option D. Congrats, Shibina, Fatima, Anaga, Akku and Naira. Okay. So there are 2 points, 1 and 2. They are at the same elevation, which means they are horizontal. Okay. So there are 2 points. It is 1, 2. Okay. They are both at the same level. So when we apply Bernoulli's equation between section 1 and 2, we can say that P1 by rho G plus V1 plus V1 square divided by 2G plus Z1 is equal to P2 by rho G plus V2 square divided by 2G plus Z2. This is the Bernoulli's equation. If both are at the same elevation, Z is always the distance from any reference point to the center line of that section. If this is the section and this is the center line, Z1 and Z2, or the Z and Z2 are any distance from the center. So if we consider this as your datum, this is your Z1. Okay, this is your Z1 and this is your Z2. So since both are at the same elevation, we can easily write that both Z1 and Z2 are gone. Okay, so what actually we need? We need the difference in pressure between P1 and P2, right? So it is P1 minus P2. Sorry, right. Okay, so just I am writing in the what P1 minus P2 by rho g is simply equal to V2 square minus V1 square divided by 2g, right? Okay, let's strike off g on both sides. So what actually is V1 minus V2? So V2 is 3V, right? So 3V square, it is 9V square. But the other one is V, so it is 8V. So it is 8 by 4 into rho V, right? So we can strike off, it is 4 rho V. Simple as it is. So the answer for this question is 4. Okay, sorry, rho V square is there. There is square, right? V square, V1 square and V2 square. So it is square also. Okay, so it is 4 rho V square. Okay. So just applying the Bernoulli's equation. Okay. Let's move to the next question. Okay. Next is also a problematic question. 2013, there is a loss, sudden enlargement loss. It is a minor loss. This is a question related to the minor loss. You can easily answer once you know the formula. You can easily answer this question. A pipe of 0.1 meter square cross-sectional area suddenly enlarges to 0.3 meter square cross-sectional area. If the discharge of the pipe is 0.3 meter cube per second, the head loss is. So, if we know the formula for finding, so what happens actually is the cross-sectional area has been increased. So, there is a sudden enlargement. So, once you know the equation for sudden enlargement, you can easily solve this question. Can easily solve this question. You have to know the formula. If you know the formula, you can easily solve it. Direct application of formula, but you need velocity, but there is given as discharge, so you can easily find the discharge also. There is no need of calculator for also. Okay. Okay, Fatima is saying A. Okay. Let's see, Fatima, what others are also saying. What happened to others? Others are not responding. It's very simple actually. If you know the equation, it is direct application of formula. Okay. Okay. Okay, so let's see what actually the answer. Yes, the answer is option A. Okay, so how to do? So a pipe of 0.1 meter square cross-sectional area is only enlarged to a cross-section area 0.3. The discharge is 0.3 meter cube per second. What is head loss? So there is sudden expansion. Okay, so actually the cross-sectional area was 0.1. This suddenly enlarged to 0.3. Okay, this is suddenly enlarged to 0.3 meter square. This is 0.1 meter square. And the discharge is, I think it is 0.3, right? So discharge is 0.3 meter cube per second. The discharge is again 0.3 meter cube per second. So what is the equation for head loss due to sudden enlargement? The equation is V1 minus V2 the whole square by 2g. So V1 will be the velocity in the first pipe, and V2 will be the velocity in the second pipe. So it is V1 minus V2 the whole square divided by 2g, but I only know the discharge. So if we know the discharge, as per continuity equation, the discharge in both the pipes will be same. That is actually what continuity equation is saying, is both the pipe, the discharge will be same. So V1 will be equal to Q divided by A1. So it is Q is 0.3, A1 is 0.1, so it is V1 is equal to 3 meter per second. Okay, V2 is what? It is Q divided by 82. So it is again 0.3 divided by 0.3, that is equal to 1 meter per second. So simply apply it. It is 3 square, it is 9 minus 1 by 2g, that is equal to 3 square 1 square, sorry, it is V1 minus V2, right? So it is 3 minus 1 the whole square divided by 2g, which is equal to 4 by 2g. So we strike off both, so we get 2 by g meters of water. That's all. Okay. So the equation for sudden enlargement is v1 minus v2 the whole square divided by 2g, and you can substitute in this equation and you get this 2 by g meters of water. So the answer is option A. Okay. Let's do one more problem. This is also from 2013 ISRO. This is the simplest problem. It is very simple. The equation you all know, and if required you can use calculator, but calculator is not required. If you know the equation, just apply the equation and from the options you can easily find. Okay, it's better you do not use the calculator. Okay, the height of water level in a tank above the center of a circular hole 2.5 centimeter in diameter is 50 meter. Okay, so the velocity of water flowing through the hole is, what is the velocity? Neglecting the friction between the jet and wall. So when there is a hole, the water coming out will be in the form of a jet, so we can neglect that friction. So that actually is the formula. Okay. It's a basic formula. I think this you studied in your engineering mechanics also. This is a basic formula. Okay. So your options are option A 20.53 meter per second, option B is 25.85, option C is 31.32, option C is 40.40. It is very basic question. The answer is option C. It is 31.32. Okay. So what actually is the question? So there is a tank, and in this tank there is a hole. Okay, let's see, let's consider this as a hole. Okay, the diameter is given 2.5 centimeter, and above it there is a liquid for a height 50 meters. Okay, so this height is 50 meter. This height is 50 meter. So water will, or the liquid will flow through this hole as jet of water. What is that velocity? This formula is very simple. V is equal to root of 2gh. That we all know. The height from the center is 50 meter. The height is 50 meter. G we know 9.81. Okay. So it is simply 2 into 9.81 into 50, which means 100 into 9.81. So it is root of 981, right? So if you have calculator, you can simply use that. If not, you can logically think. Root of 981, right? It is the root of 981. Root 981. So we know that the square root of 900 is 30, or the 30 square is 900. So what actually can be the square root of 981? Can it be 40? Never, because 40 the square is 1600. There is no chance it can be 20 or it can be 25. So the answer is what? 31.32. So if calculator is not provided, also we can solve this question from the equations. Okay. So the answer is option C, 31.32. Okay. Let's move to the next question. Okay. So this is question about open channel flow for asked in ISRO 2014. Just give it a try. So the Fruits number is given, so you have to know what actually is the Fruits number. If you know the Fruits number, you can substitute in the equation and you can solve and find, but you need calculator, because there is, when we apply the formula, the power is with a higher value. Okay. So a rectangle open channel of width 5 meter is carrying a discharge of 100 meter cube per second. The Fruit's number of the flow is 0.8. The depth of flow in the channel is. So if you know the formula of Fruit's number, you can simply apply that concept and solve and find the answer. But you require calculator for this because the power you get will be in form of fraction. So you require calculator. Just give it a try. I will explain. So what actually is the Fruit's number equation? You know. If you know, you can use that. What actually is the equation for Fruit's number? Shibana is saying SA others are doing okay. Okay, let us see what actually is the answer. The answer is option A. Okay, so in an open channel the width is 5 meter and the discharge is 100 meter cube per second. What is the Fruit's number is 0.8. What is the depth of flow is actually is the question. So the equation of Fruit's number is Fr is equal to V divided by root GD. This is the actual equation. So what actually is D? D is the ratio of, or D is the hydraulic depth. Hydraulic depth. So it is the ratio of wetted area to top width. So it is a rectangle, right? So rectangle, the area will be B into Y. If Y is the depth of flow and it is divided by B is the top width, then we can strike off that. The answer will be Y. Okay. So what actually is Q? So what actually is V? Velocity is not given in the question, right? They have given the discharge. So discharge, if you know, velocity is Q divided by area. So again it is Q divided by B into Y, right? So let us write this. So it is Q divided by B into Y into root G into Y. Okay, and this is equal to your Fruit's number. The Fruit's number is given in the question as 0.8. That is equal to Q discharge. What is the discharge actually given in the question? Discharge is 100 and the width is 5. Okay, so the discharge is 100 and the width is 5. And it is Y into Y, so it is Y raised to 3 by 2 into root G, so it is root 9.81. Okay, so you can strike off this is 20. Once you cross multiply, you get Y raised to 3 by 2 is equal to 20 divided by 0.8 into root G, right? 20.8 root G. Okay, so it is, so what about Y? It is 20 divided by 0.8 root G the whole raised to 3 by 2. You solve, you get the answer as 4 meter. So this is the answer. So once more I will explain this question. So Fruit's number, the equation, or the Fruit's number is the ratio of inertia force by gravitation force. There is a root also. So you get the equation as V divided by root GD, where D is your hydraulic depth. What actually is hydraulic depth? It is the ratio of wetted area to top width. It is a rectangle. So the area will be B into Y divided by top width is again B. So we strike this and we have Y. So it is Q divided by B into Y, because velocity is required. We already know the discharge. So discharge by area, rectangle, it is Q divided by B into Y. So it is Q divided by B into Y into Q root G into Y. Okay, so Q is 100. Fruit's number is given as 0.8. The other width is 5. Y, it is 1 and 1 by 2, it is 3 by 2 in root 9.82. Okay, so once you substitute, you get Y is 3 by 2 as some value. So it is opposite side, it will be getting, sorry, it is not 3 by 2. When it is gone upwards, it is 2 by 3. Sorry, it is 2 by 3. So Y is equal to 20 divided by 0.8 into root G raised to 2 by 3. You solve it, you get an answer as 4 meter. Okay, so the answer is option A. So you require calculator for this question. There is no other option. So the answer is option A. Okay. So let's move on to the last question of today's session. Okay. Yeah. It is again with the Fruit's number situation. Just give it a try. So the slope is given. You can follow any method for finding or solving this question. Okay. So the situation is what? So a trapezoidal channel with a base of 6 meter, side slope of 2 horizontal to 1 vertical conveys water at 17 meter cube per second with a depth of 1.5. The flow situation in the channel is critical, supercritical, subcritical, or none of the above. For this solution or to find the type of flow, you require Fruit's number. That is a basic thing you require. So already you know the value or the equation for finding the Fruit's number, right? It is V divided by root GD. So here it is a trapezoidal channel. The last question was a rectangular channel. So just draw the figure, understand what actually is the D, what is the top width, what is the wetted area, no, wetted pavement is not required, what is the wetted area. Just substitute values, rearrange it and find the Fruit's number. And then accordingly you find what is the type of flow. Okay, so here you have to find the Fruit's number. Just give it a try. So think about the formula of Fruit's number. It is V divided by root GD. Find what actually is D. Again the discharge is given, so you are required to find the velocity. The values are given. So find the velocity, substitute the values and you can get the answer. Swati is also saying C. Naina is also saying C. Okay, so what actually is the answer? So it's not B. It's not B, it's C. Okay. The answer is C. The flow is subcritical. Okay. So you have to find the Fruit's number. Fruit's number, the equation you know. So let's first draw. Okay, just a minute. Okay. So first of all, just draw the trapezoidal section. So this is the trapezoidal section. The bottom width is given us actually 6 meter. Okay, this is the bottom width. And the slope is also given, right? The slope is given us 1 vertical to 2 horizontal. Okay, fine. So we can draw like this and this. So this is 6 meter. Again, this is also 6 meter. No issues. So the depth of flow is already given. The question is 1.5 meter, right? So if this vertical is 1.5 meter, for 1 the horizontal is 2. So for 1.5 what will be the horizontal? 1, the double is 2. 1.5, the double is 3. So this is 3 meter. Again this is also 3 meter. Okay. So you get the top width as 6 plus 6, 12. You will get the bottom width as 6 meter. So what actually is the D? D is wetted area divided by top width, right? So it is half. H is your 1.5 into A plus B is your 12 plus 6. Half H into A plus B is your. Then again your top width is 6 plus 6, it is 12. Okay, this is your D. So I require Fruit's number. The equation for Fruit's number is V divided by root GD. I don't know the value of V, but I know the value of discharge. What actually is discharge is given in the question. It is 17, right? So 17 divided by area, you get discharge. So this is your area. I think this value will be around 13.5. Okay. So Q is equal to 17 divided by 13.5. You get the discharge. You can substitute this value in the equation of velocity divided by root G. What is the Fruit's number actually you are getting? Can you tell? Naina, Swati, what actually Fruit's number you get? So the wetted area is 13.5. You get the wetted, sorry, you get the D value, wetted area by top width. So again, discharge is area divided by, sorry, discharge divided, sorry, velocity. Velocity is discharge divided by area. So 17 is the discharge, area is half H into A plus B. So it is 17 divided by 13.5 is your ratio of velocity. You can substitute this velocity in the equation. G is already we know, D also you can find this, and you get the Fruit's number as, yeah, you have said it is 0.38 or it is 0.37. okay, because the value is not important. So once you get the Fruit's number value as less than 1, we can say that the flow is subcritical. So remember, if the Fruit's number value is less than 1, the flow is known as subcritical. If the value is equal to 1, the flow is known as critical, and if the value is greater than 1, it is known as supercritical. Remember, okay. So once you get the Fruit's number value as less than 1, then it is close to question. The answer is subcritical. The answer is option C. Okay. So this is actually what we are discussed today. Hope you all understand the concept. For fluid mechanics, don't skip this subject because the question has asked. Okay. So also don't forget to buy this if you required, or the test series. Okay, both will be useful for you. All the buying link will be given in the comment box. Okay. So thank you.